Hi, I'm Jake, and we're back again with the mill. So in the part 2 of this series, I'm going to show you some little tips and tricks with the nitty-gritty details of working and running the mill. This first tip is pretty necessary. There should be a 3/4 wrench always kept with the mill, because that's the size of this hex for moving in and out and tightening the vise, and it's also the size of the drawbar at the top. So that is a very handy wrench when using the mill. Another thing you'll need to know, and something I'll need 2 hands for, is zeroing the mill onto a surface. So what you do is, over by the CNC computer over here, there will most likely be a piece of paper. Now, don't rip this paper, because obviously this one has calculations on it, but use it carefully. So, here we go. What you want to do is move this back and forth while slowly adjusting the knee to bring the bit down. You can see, stopped moving it there, show it again. So it's about there. So that's how we find our zero. And to re-zero it, I like to keep it in the knee in the down position, just because that's the easiest to approximate to. Next, we have the suggested cutting feed. I'm going to bring this bit so that it's off of the work. Awesome. Now, how far should we go down on each pass of this? How much should we take away in one pass? The general rule of thumb that I've been shown is 1 turn of the knee. And that is far sufficient enough to take off enough material. In this case, that's probably maybe as much as you want to do. With some of the small ones, you may be able to go, small bits over there, you may be able to go a little bit further because it's taking out less material on each pass. So let's get into this cutting. So since this is in the high position, it's running at 1600 RPMs. I'm going to put it into what's called the low range, because that spins it clockwise, which is the correct cutting direction for this bit. Now, I want to make sure that I take about a half of a bit's width. So that's a bit much. Excuse my pun. That's about right. It's about half of a little bit under the radius of the bit, and then we can start feeding the bit into the work. And once we get through, we can jog it 1 cycle down and pull it back through. Now, this operation that I'm performing here is called squaring the work. And what it does is it makes, if the head is properly trammed, that is, if the spindle here is really perpendicular to the table, then what will happen is that this top surface that I'm milling off here will be perfectly perpendicular to the sides of it, which are held in by the jaws of the vise right now. This means that I can know, well, granted I rely on the accuracy of the tramming of the head, that this work is square. Now, it won't stay square for very long because it's wood and it'll splinter and things like that. But if I were milling, say, metal, it is a very, very good way of making sure to know that your square or cube or whatever is perfectly flat. Now, I'd like to say a word about utilizing the digital readout correctly. Say I want to make this corner the 0 to take my measurements from. What I can do is, once I secure the piece in the vise, I can move the bit out from above the workpiece and raise it so that it is below the plane of it. So that's about right. Now, I want to make sure that the cutting angle, the teeth, these are in the correct, like sticking towards the work. And to do that, I can take just a wrench on the drawbar without activating the brake to manually turn this much easier. So just bring it into contact real quick. Cool. So that's in contact. And now what I can do is, since this is my X direction, and I know this bit is a 3/4 size bit, I can first 0 in the X direction, and then enter in a value for X, and put in half of what it is. And for any difficult sizes, you can pull up a calculator on the CNC computer, enter in the size to get the radius. So for this bit, it's 0.375, and I can enter this in as 0.375, enter, and I think I got the direction correct. Nope. And see, that's one of the things you'll have to be aware of. I entered it in as positive 0.375, when it should have been negative 0.375. And now, if I raise this above the edge real quick, when I bring that to what it looks like directly over the edge, it's approximately 0. And then I'll put it 0 on here, roughly, and that's directly over the edge. Now, I'll just do the same thing for the Y direction off camera. Now that I've zeroed both of the directions directly over that corner, I can take my measurements directly off of the digital readout into, say, the position of this hole. One thing that I forgot to mention in my first part, but I will mention here, is the table locks. Now, for the Y direction here, there's one lock under here, you can lock it in, and then prevents movement here. And then there are also 2 X locks, one here and one over here, for making sure that the table doesn't move in the X direction. There also is one on the knee down here, but that one's very rarely used, as this is fairly stable as it is. One thing that I showed, but not in much detail, was this spindle brake. Here. If I get it running, and then I shut it off, I can stop it immediately by activating that brake. I'll show you one more time. Shut it off, immediate stop. So, besides this collet ring over here, that you can just pick up some collets from when you need them, when changing out the bit, that's about it on the machine right now. Every once in a while, you'll have to pull this lever over here on this oiling machine. I still have to do some more cleaning and research on that. But besides that, make sure you wear your safety glasses in the lab, clean off the machines when you're done, and you'll have a great time working in the shop.